Okay. Okay, there you go. So just want to remind you, although I'm sure you're all aware of this, we have the second data science Nexus conference, which will happen from May 19th to May 21st. And I encourage everyone here to register. For students, the registration fee is $25. And you can find more information on the website here. So you can also just Google Data Science Nexus U Manitoba, and you should find it very, very easily. But without further ado, I want to introduce you to the three challenges from our three, I guess actually it's 5 sponsors. So you get a sense of the different challenges. So we'll start with Emily and the University of Winnipeg, which have a challenge that has to do with digital agriculture. They're not with us today, but they shared a video for us with us. So I'll just play this video and hope that I can actually make it work correctly. So just give me a second.
Good afternoon, my name is Jacqueline Kina. I'm the Managing Director of Emily, or the Enterprise Machine Intelligence and Learning Initiative here in Manitoba. I'm really pleased to talk to you today about the Data Science Challenge that we have sponsored here at the Data Science Nexus Conference at the University of Manitoba. It was really important for us to be a part of this conference, especially the Digital Agriculture Day, and to present a challenge because we wanted to highlight all of the amazing opportunities for data science students and graduates in the province of Manitoba, specifically related to digital agriculture and the whole of the agriculture industry. There are so many interesting roles in the industry for data science graduates, and I hope that through this challenge and through attending the conference and hearing from our industry and academic speakers, you get a bit of a handle and a bit of an idea about how broad the opportunities are and how much data science experts are a vital part of the industry and will continue to be. So the challenge statement for the challenge that we've proposed as part of this conference is to develop an algorithm that can distinguish each individual type of plant, be it crop or weed, from each other. Some traditional models have only distinguished what is a weed in a field. So for example, you might go into a field of wheat and the algorithm would only be able to distinguish everything that is not wheat. Once you have decided, I'm looking at a field of wheat, that is the preferred outcome, and everything that it is not, the algorithm can point out. So that is one possible option for how technologies work in this space, but what we're looking for is actually plant versus plant identification and distinction. And so what we're looking for is an algorithm that can distinguish each individual type of plant, whether it's a crop or weed, from each other based on the data set that we have provided for the challenge. This is a really important task, and lots of people are working in this, on this in the industry as we speak. All sorts of companies are looking to be successful in this area because some of the benefits, of course, are when producers have a more accurate knowledge of what's going on in their field and which specific weeds or which specific volunteer crops are growing in their field, they can optimize production decisions and treat those more precisely. And being able to apply that precise level of care in the field leads to increases in productivity and significant increases to sustainability. I've skipped a few slides here. Here we go, here's the challenge. So you can see a little bit more about the kind of test or the kind of data set that we are providing here. This is through a great project that we're involved in the University of Winnipeg. These are some example images of the 4 different plants that are imaged in the data set. You can use a machine learning model of your choice. We have a few suggestions there at the bottom, but by no means is that a requirement. Here's a little bit more information about the data set. It's sorted into two different folders, a training data set as well as a test data set. And in the challenge statement document that will be posted on the web or perhaps already is up online after this information session, I would call your attention to a few links that we've actually linked inside that document. First is to more information about the project that we have going with the University of Winnipeg. They are developing a massive labeled data set of prairie crops and weeds. It's very exciting, and it really is quite leading edge in digital agriculture, especially in Canada, to be developing a labeled data set of prairie crops and weeds through both growth chamber and lab data, which is what is used here in this challenge, as well as in full-scale fields each growing season. And these are some images that we collected last year in full-scale fields here in Manitoba, and we're going to be doing just in a few weeks again this year. And of course, here are the prizes. You may be aware, we're going to be evaluating the effectiveness and accuracy of the algorithm submitted at distinguishing between each individual plant in the data set. And we will be awarding 3 prizes on May 19th at the conference. So thanks very much. And please reach out to us. The conference organizers perhaps are best to ask questions related specifically to the hackathon, but please connect us because we're certainly excited to hear from all of you and connect more data science experts to industries here in Manitoba. So thanks very much.
Okay, so that was a short presentation by Jacqueline Keena from Emily, and I can confirm that the project description is already on the website. So please have a look at this if you're interested in more details. So that was the first challenge. The second challenge is from our 2 sponsors, so Winnipeg, the City of Winnipeg, and also Ground Level Insights, which are collaborating on a interesting project related to public health. And to talk a little bit about this, we have Jennifer Barnachuk from the City of Winnipeg, which will be sharing a few slides, I think.
Yes, thank you, Max. Let me share my screen. Okay, I think you should be able to see it now. All right, well, thank you so much. I'm glad to be presenting here today. As Max said, I'm Jen Bondarchuk. I'm the Senior Data Scientist at the City of Winnipeg. So I will be the contact point for all questions about the city or clarifications required from the city. If I don't know the answer, I will hunt it down for you and I'll find it. We have lots of data experts at the city on all kinds of things. The city is partnering with Ground Level Insights, and the CEO there is Asif Khan, who's also the keynote speaker on day 2. So we're very excited to be offering this joint challenge for you. The theme of day 2, of course, is public health, which right now largely concerns the current pandemic. So the question that we are posing for our student challenge is, can population movement and traffic patterns predict public health outcomes and inform preventative measures in a pandemic in Winnipeg? And the purpose of this challenge is to demonstrate how governments and industry and citizen data scientists can work together to address challenges using this current public health pandemic as a use case. Ground Level Insights will be providing a simulated data set to student teams who accept this challenge, and we are encouraging students to access the open data portals of both the City of Winnipeg and the province of Manitoba. So I will tell you a little bit more about each of these data sets. Ground Level Insights provides analytics and insights on population movement. They do this through collecting, analyzing, anonymizing, and aggregating privacy-compliant data that empowers governments and businesses to make tangible, actionable decisions. This slide shows some of the kinds of data sets that they collect, including SDK data, sensor data, IP location data, cellular data, and social media data. Their patent-pending AI technology converts this information into real-time movement data, which, as I said, will be simulated for purposes of this student challenge, and more information can be found on their website. second data set that we're going to direct you to in this challenge is the City of Winnipeg's open data portal, and specifically the permanent count station traffic counts. This data set comprises directional traffic counts, so the numbers of cars moving in each direction on many streets around the city. The data has been collected since January of 2019, so you have a bit of year-over-year comparison data available. It is updated daily and counts cars every 15 minutes. So that will give you an indication of another indication of movement around the city. So the third data set that we are using for this challenge is the province of Manitoba's open data portal with all the COVID data. So I've been checking out this open data portal over time, and it's getting better and better all the time. They're organizing the data better and sharing more data. So there's a lot in there, and I think you will be able to find enough to support the exploration of this question. And if you're focusing specifically on the City of Winnipeg, you'd be looking for the Winnipeg Regional Health Authority data that is contained within the province's larger data sets. These data are also updated daily. So back to the question, and so in this challenge, we're looking for a demonstration of whether and how population movement and traffic patterns can be used to predict public health outcomes. I admit I don't know 100% like what to expect with this. So I'm very excited to see what the students come up with. This is kind of a creative challenge about how would you look at this question. Also, as a data scientist working in government, this is sometimes the extent of the information you're given when you're asked a question by the executives or the policymakers of like, what do we do? Here's some data. So I think it's an interesting challenge in that way for the students. And I am personally have a ton of questions about how you can approach this. And I really look forward to seeing what can be done with this challenge. So thank you very much.
Yeah, thank you very much, Jen. I guess before we move on to the next the next challenge, I'll open it up for questions if anyone has any question about this particular challenge for Jennifer. So you can raise your hand, or you can ask the question in the chat, and then I can repeat it to Jen. Okay, well, I don't see any question yet, so maybe let's go to the next challenge, and we can circle back for questions. And so for the third and final challenge, we have Dave Fulacqua from Bison Transport, who has an interesting challenge that has to do with transportation, which is the theme of the third day for the conference.
All right, I'll see if I can effectively share my screen as my colleagues have before me. All right, you should all see a map, do you?
Yes.
All right, so this presentation will be a little more simple, and but I want to just get to the essence of the challenge. First of all, blessed to be part of this. Max, thanks for being a co-pilot for us as we navigated our first time being involved in it. Great to see so many organizations involved. Great to see some familiar faces. Carson Long, hello. It's been a while since I've actually seen you face to face, and so we're excited to be part of this whole program. We're excited to be part of the conference and excited to be directly involved in the Student Data Challenge. So as you can imagine, supply chain networks are complicated through COVID. They have gotten a new level of complication. The greatest level of complication exists in two things. Number one, enhanced driver safety protocols. So our drivers cross the border about 15,000 times a month across our entire fleet. And our COVID infection rate is a fraction of the whole population of Canada in terms of a per capita basis. So we know our safety programs are being effective. In addition to that, COVID, though, has thrown us a variety of curves in terms of demand. You can imagine that back in February, March of last year, when everybody was buying toilet paper, and then everybody was buying food, and then everybody was at home, so they stopped buying both things. But it was a very interesting time for us to be truckers. So the map you're looking at here is a representation of the transactions within a 3-month period in our network. It does look quite complicated. It is quite complicated. You can see that we have broad coverage across the entire country of Canada, and a vast coverage throughout the US. We do actually get down to Florida. I'm just going to circle it right here. That dot in the Carolinas actually is a region, and the region covers that south area. So we do get to all 4 corners. The purpose of the challenge that we're putting towards together, or that we have put together, that we put before you as students, is to help us understand the rhythm of a particular network, both inbound and outbound, so we can effectively forecast the availability. Oh, I lost my screen somehow. Did you lose? Can you still see my map? Oh, timed out. Sorry, I'll just be a minute. So we can effectively understand the inbound arrivals and the outbound requirements for customers in a particular region, and that region is Quebec. And so I'm pointing at the region right now. As you can see by the size of the dot, the larger the region it is. It's sort of a medium-sized region for us, and so it has a level of complexity. It might not be as complex as some of the larger ones. The beauty of it is there is a really wide variety of inbound and outbound customers. That we have drivers that live there. We have lots of drivers that come in and go from Quebec who don't live there, because they're doing that to be able to go in and deliver a shipment and go beyond. And so what we're talking about, and I would just simply use the word balance. What is the balance of inbound and outbound shipments? And how is the balance comparing? Are there more inbound than outbound, or are there less inbound than outbound? So really, the idea here is to be able to define the balance and to be able to forecast the balance effectively, so that we can manage imbalances. Imbalances are tremendously inefficient for our network. If we have too many drivers inbound with not enough shipments outbound, we could potentially end up running empty miles, sometimes 300 or 400 empty miles, and our business is a very, very narrow margin. And so we really can't afford to do that very often. If there are more outbound shipments than inbound, we are either making customers wait, which can frustrate them, or giving loads back, which frustrates customers and takes revenue away from us. So if we effectively manage that inbound and outbound balance, we know we can serve customers well, our fleet will run efficiently, and then we have the potential to earn a profit. Very much 3 key elements that are involved in our greatest concerns in the balance equation. And this is part of our profile, the challenge profile that we posted on the website. The first thing is timing. The date and time of arrival of a particular shipment, and the date and time of a departure of a particular shipment, the required delivery date versus the arrival time of the inbound shipment, and then the transit time required, the amount of time it takes to go from the origin of the shipment to the destination of the shipment, all matter. Timing matters. Geographic properties really matter. The origin region of the shipment, that is inbound to Quebec, like where it comes from, and the route it takes to get to Quebec, and the destination region of the outbound shipment, to be able to understand what market it's going into and how long it'll take to get there. Equipment properties are also very important, because a customer who's shipping refrigerated food cannot receive a non-refrigerated trailer. A customer that is shipping something that's particularly heavy may not be able to use a refrigerated trailer, even though the order might fit on the trailer. Refrigerated trailers are heavier than non-refrigerated trailers, and so there are other elements here as well. There also is a resident inventory of trailers in Quebec to allow for some friction between shipments arriving and shipments departing, to allow us to manage, I'll say, match for time the inbound and the outbound driver. Last thing is a little bit of a profile on our Quebec region. Quebec has a wide variety of inbound and outbound shippers from many different regions in Bison's network. The balance is subject to seasonal and other customer-related fluctuations. One particular one that sticks out to me is for 2 weeks in Quebec, there's a construction holiday. And so for weeks before that construction holiday, construction materials drop off substantially. Some of our customers produce housing insulation. So those shipments drop off dramatically right before the holiday. They don't come in at all during the holiday, and then they ramp up substantially just after the holiday. So very interesting, unique circumstances in Quebec. At the end, our desired outcome is to have an algorithm set that creates a forecast that clearly and accurately identifies the imbalances by timing and equipment type, and then would clarify the pending needs and provide focus for proactive decision-making and problem solving. This proactive problem solving will drive the bottom line, because often an imbalance where there's not enough shipments coming in and too many going out, often that imbalance is simply negotiating with the customer to say, 3 of your shipments for tomorrow, can I move them off till the next day? And then you can create balance. So there are, if we can see it early enough, we have the ability to be able to manage that balance in a variety of different ways. The foundation of the forecast is to match inbound and outbound data accurately, along with equipment type, origin point of the inbound shipments, and promote efficiency. The forecast should call out days when the match is poor, and offering clarity for the size of the poor match, and also encourage proactive steps to address the balance. Similar to the last presentation by Jen, and by the way, Jen, no questions at the end doesn't necessarily mean it was a bad presentation. It might have mean you answered every single question, which you probably did. And our prizes are the same: $250 for the first team, $150 for the second place team, and $100 for the third place team. And this will be an evaluation of the meeting of the elements that are listed in the desired outcome section of the challenge profile. So that's all I have today. Thanks for having me.
Thank you very much, Dave. Do we have any questions for Dave or for Jennifer about the challenges? This is exactly like when I teach. Nobody's speaking up. Yeah, I don't see any. Oh, okay.
So that was more of a peanut gallery kind of comment as opposed to a question.
Exactly. So, okay, then maybe I'll just go back to my slides. I still have a few slides that I have to do with the challenge in general. Okay. And so, yeah, right. So just to give you an idea of the timeline for the challenge. So at the end of this week, so on Friday, April 30th, is the last day for registering for the challenge itself. And then you can, of course, you can still register for the conference until I guess it's the 3rd week of May. And the challenge itself will start on May 1st. And so depending on which challenge you chose when you registered, you'll get details about how to access the data and what are the criteria for the solution and what kind of a format you should submit your solution. All of that will be shared with you on May 1st. And then you have 2 weeks to complete the challenge. So the challenge itself ends on May 14th. And the winners will be announced during the conference. So at the end of the day, we have a few minutes where the winners will be announced. Each day has a different theme. And so each theme matches one of the challenges. So for example, on Wednesday, we'll have we'll announce the winners for the Emily challenge. So the digital agriculture and etc. And here, so the team who finishes number 1 will have the opportunity to present actually their a poster or their solution for the particular challenge. So that's a great motivation as well, so that everyone can see what you did and appreciate what you offered in terms of solution. So all of this will happen during the conference. And also all participants are encouraged to present their solution during our poster session, which will happen in the afternoon of the conference. So each day, again, we'll have a theme, and so you can present your solutions during that day. So to participate in the challenge, you don't need to register to the conference, but I still encourage you to do so. And because if you want to present your poster, you'll need to be registered. And right, so again, the challenge descriptions can be found on our website, our webpage. You can see the link here, but again, if you look up Data Science Nexus Conference U Manitoba on your favorite search engine, you should find it pretty quickly. Okay, so this is the end of the info session. That's the information I want to share with you. Thank you again to Jen and Dave for presenting your challenge a little bit more. And I'll try once more. I'll try to open it up for questions. Oh, I can see some things in the chat. Will all the slides be posted? I guess I'll start with the first one. Are we able to register for more than one challenge? No, the answer is just you have to pick one challenge. I think 2 weeks is a pretty tight deadline for submitting a solution. So I think you can really only focus on one challenge. Thank you, Kimia, for sharing the link. Will all the slides be posted? You mean the slides that we used for this presentation? I guess we haven't really thought about this. This is being recorded right now, and so a link to the recording will be shared on the website afterwards. So then you can refer back to it that way. Okay, so here's another question. My team already registered for one challenge because it was the only available option. Are we able to change challenges before registration ends? Yes, that's not a problem. You can send me an email, I guess, and I can fix this. I'll just share my email address in the chat. And then just tell me which challenge you want to choose instead. Okay. Any further questions? No. Okay, well, I guess we can end this here. Thank you again, everyone, for joining us today. I'm really excited about these 3 challenges, and I hope you are as excited as I am. I encourage you to register for the challenge, and I hope you can also encourage your friends to do so. I think we have nice prizes, and the conference is also going to be very interesting. So I encourage you to register for that as well. But if we don't have anything else, I'll just wish you a good day, and I hope to see you all soon.
Thanks, Max. It's good to see you.
Okay. Bye, everyone. Bye, Dave.
Bye.